Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video we are going to troubleshoot service provider network, and this is my scenario in front of you. As you can see in my scenario, there are two sides of a customer, side 1 and side 2, and both the sides are connected together through service provider network. In the service provider network, I have four routers, router 1, 2, 3, 4, and I have one loopback on router number 1 where I am running IP 1.1.1.1, and I have one loopback on router number 4 where I am running IP 4.4.4.4. In the service provider network, I am running IGP protocol OSPF for internal reachability. Through OSPF, we have reachability between 1.1.1 and 4.4.4. And then we are running MPLS to forward traffic on the basis of labeled. Because router 2 and router 3 are not going to store customer prefixes, these are P router, right? So router 1 is P router, router 4 is also P router, who is connecting customer and provider network. And to exchange customer prefixes, like customer side 1 LAN prefix means 10.1.1.0/24 to side 2, and side 2 prefix 20.1.1.0/24 to side 1, we have BGP session between 1.1.1 and 4.4.4. In the service provider network, I am running BGPS number 500, but BGP is only running on router 1 and router 4, right? We don't want to inject customer prefixes in the routing table of these router 2 and router 3. But after configuring everything, after enabling MPLS in this scenario, right, here we are running MPLS, after enabling OSPF on all R1 to R4 routers and enabling BGP, right, between P to P as well as between P to CE, right, here also we are running BGP. Here BGPS number is 100, here BGPS number is 100, right? So here guys, between P to C, this is customer is, this is also customer is, this is provider is, and this is another provider is. So between P to C we have eBGP, here also we have eBGP, and between P to P I have iBGP, right? But here is some issue you can see. After configuring the scenario, side 1 and side 2 are not able to communicate, right? So first of all, we are going to verify the issue, and after that we'll troubleshoot it, fix it, right? So let's verify the issue, guys. Let me access router 5, which is the side 1 of customer, any customer, let's say customer A. Let me access this router. And show IP BGP. You can see in the BGP table on router number 5, I have both sides prefix LAN subnet. 10.1.1.0/24 is there, and 20.1.1.0/24 there, right? Let me check the connectivity. Ping 20.1.1.1 and source 10.1.1.1. 20.1 is the host inside 2 and 10.1 is the host inside 1, right? And you can see ping is not working, and whenever there is no connectivity, then guys, the first step of troubleshooting is checking routing table, like destination route is there in the routing table or not for the destination IP address, right? So for an example, here I can run command show IP route and 20.1.1.1. So you can see route is there in the routing table, and this prefix, this subnet is non via BGP. BGP is number 100, it is eBGP, that's why distance is 20. Okay, and the last update from 15.1.1.1. 15.1 is nothing but the router 1. Between router 1 and router 5, I am running this subnet 15.1.1.0. You can see the subnet between all the routers. Okay, so fine, route is there in the routing table of R5. Still LAN users are not able to communicate. So definitely maybe route is not available in the routing table of router 6. So reverse path is not there between side 1 and side 2. So let me access router 6 also, and here also I try to ping 10.1 means host in side 1 from host of side 2, and you can see ping is not working. Here also we can verify the routing table. In the routing table, route should be there for 10.1.1.1, and show IP route 10.1.1.1. You can see again guys, route is there in the routing table, right? And the prefix 10.1.1.0/24 is again non via BGPS number 100. Distance is this one, and it is receiving from 46.1.1.4. Between router 4 and router 6, my subnet is 46.1.1.0. So 46.4 is nothing but the router number 4, right? So we have verified the customer edge routing table, right? In the customer edge routing table we have route, right? That means we don't have any issue on customer router, because definitely BGP neighborship is there. So IP BGP summary, then only I am receiving prefixes, you can see here. And on router number 6 also, so IP BGP summary, route is there, correct? So we have verified the customer routers. On the customer routers configuration is correct, even route is there. That means there is some issue in the service provider network. Even in the service provider network guys, this BGP pairing is fine, right? That's why we are able to exchange the prefixes. BGP pairing is 5. For an example, if I will talk about R5, so R5 is advertising this subnet 10.1.1.0. so IP BGP, you can see in the BGP table we have this subnet, and who is their neighbor, so IP BGP summary 15.1.1.1. so you can see to this neighbor it is advertising one prefix, one subnet, right? Even you can check which subnet it is advertising, so IP BGP neighbor and 15.1.1.1 advertise route. You can see 10.1.1.0/24. next hop is 0.0.0. Fine. Now let me access R1 router 1 P router, and on the P router, so IP BGP. Even we don't need to verify the BGP table because guys, route is already there, right? So here also you can see both the subnets are there, and so IP BGP summary, right? Two neighbors are there. One is 4.4.4 iBGP neighbor router 4, and another one is customer is router, right? So here on router number 1 we don't have any issue. On router number 4 also you can check, we don't have any issue with BGP. So IP BGP summary, fine, and so IP BGP. In the BGP table both the subnets are there, so we don't have any issue. That means service provider routers are not able to forward the traffic. So to troubleshoot it, what we have to do, we have to check the packet flow, why ping is not working. So let's do one thing. When guys any host from side 1 will ping any host to side 2, source IP can be 10.1.1.1 or 10.1.1.2, destination IP can be 20.1.1.1, or any IP address from the destination subnet. It will forward, user will forward traffic to router 5. Router 5 will check their routing table, so IP route, and it will compare destination IP address. Even it will not check routing table, maybe it will check SAP table, so IP SAP and 20.1.1.1, and you can see in the SAP table entry is there. Next hop IP address is 15.1 router 1, and exit interface is fast ethernet 0/0. So router 5 is going to forward this traffic to router number 1. Fine. Now router 1 is again going to check their routing table R1, so IP SAP, it will check by the way of IV table, SAP table, SAP and 20.1.1.1, right? In the SAP table you can see route, there is one label, so router will get to know that we need to add label with the traffic. And next hop IP address is 12.2, which is router 2 IP address, and exit interface is fast ethernet 1/0. So router 1 is going to add label over here. Which label it will add? It will add label 17 in the MPLS header, and after that it will forward traffic from F1/0 to router number 2. When router 2 will receive, router 2 is not receiving normal IPv4 packet. Router 2 is receiving what? Labeled packet. So when router 2 will receive labeled packet, then it is going to check their FIB table, LFIB table, right? Label forwarding information based table. It will compare the label, it will swap the label, and then it will forward the traffic, right? So router 2 is not going to open routing table. Even if it will check the routing table, so IP route 20.1.1.1. So you can see, sorry, this is router 1 on router number 2. On router number 2, if you will check routing table, so IP route 20.1.1.1. So you can see network not in table, Because guys, from router number 1 we are not advertising this LAN subnet of customer to router number 2. We are not advertising it in OSPF. We are advertising it in BGP, right? In the BGP only. So BGP peering is there between router 1 and router 4 only. So router 2 and router 3 will not have route, and even router 2 and router 3 is not going to compare destination with their routing table, because this is labeled packet. Whenever router receive labeled packet, it check another table that is called MPLS forwarding table, or you can say LFIB table. And in the LFIB table, it is going to compare the label. What label is coming? 17. So where is label 17? Local label 17 is over here. Is there any remote label, guys? No, remote label is not present. No outgoing label is there for traffic, right? That means router 2 is going to pop the label. That means router 2 is going to pop the label. It will remove the label, right? And here is some issue. Why router 2 don't have label for 4.4.4.4? Right? Router 2 should have label for 4.4.4, and that is going to be remote label for 17. For local level 17, here remote label should be something for 4.4.4.4. So here is one issue. Now why we have this issue? Why we don't have label for 4.4.4? Do I have label for 1.1.1? For 1.1.1, at least it's saying pop the label, right? Means there is label, guys, label number 3. But for 4.4.4, there is no any remote label. That means there is some issue with MPLS. That means there is some issue with MPLS. So here what we will verify? We'll verify the MPLS. We'll check is MPLS running fine or not on router number 2. So MPLS interface. Here you can see MPLS is enabled on both interfaces. MPLS is enabled on both the interfaces. Let me check LDP neighborship. Which protocol we are using? LDP, right? So router 2 should have 2 LDP neighbor. So MPLS LDP neighbor. And here you can see, guys, here is the issue. We don't have any LDP neighborship between router 2 and router 3. There is only one LDP peer, right? Peer LDP identifier is 1.1.1.1. It is router 1, right? Not router 3, and don't have any other peer, right? So we don't have LDP neighborship between router 2 and router 3, right? This is the main issue. Why we don't have LDP neighbor here? Let's troubleshoot it. Maybe MPLS is not enabled on router number 3. Let me access R3 and let me show you the MPLS enable interfaces. So MPLS interfaces, here also you can see MPLS is enabled on both interfaces, fast Ethernet 0/0 and fast Ethernet 1/0. MPLS is already enabled. So MPLS LDP neighbor, but there is no any neighborship, right? Router 3 don't have any LDP neighbor here. Now question is why? Let me check the MPLS configuration here. So run interface F 0/0. So MPLS is not enabled on this particular interface. SAF is running. So IP SAF, let's say 4.4.4.4. Yeah, SAF is running. And so run section OSPF. In the OSPF, maybe we have enabled the LDP. Yes, here you can see. In the OSPF, we have enabled the LDP protocol, right? So this command MPLS LDP auto config will enable MPLS on all OSPF enabled interfaces, right? But why we don't have LDP neighborship here, guys? If MPLS is enabled on both the interface, debug, you know, MPLS is or LDP is a TCP based protocol, so we can verify the TCP connection also. So TCP brief. Here you can see between 30.1.1.1 to 23.1.1.2. 30.1.1.1. Where is 30.1.1.1? This is the issue, guys. 30.1.1. 23.2 is fine. 23.2 is router number 2. Right? So router 3 is trying to establish TCP connection between with router number 2 with 23.1.1.2, and it is using their own IP address what? 30.1.1. means on router ID of router 3 is what? 30.1.1.1. Router ID of router LDP router ID of router 3 is 30.1.1.3. So MPLS LDP, and here we can say neighbor is not there, we already verified that. Then we can check LDP binding. So this is binding table. Okay, fine, binding table is there, and so LDP okay, these are the fine. So LDP, is there any other command available? Discovery. Okay, here we can see one thing, guys. Local LDP identifier is 30.1.1.1. So why router have elected this IP address as a router ID? Maybe this is the IP address on router, you know, the highest IP address on the router will become LDP router ID. So IP interface brief. Yes, we have one loopback 10 where I am running IP 30.1.1.1. So this IP address is the LDP router ID. Guys, if 30.1.1.1 is the LDP router ID, then make sure LDP router ID of router 3 should be reachable from R1, right? So on router number 2, so IP route 30.1.1.1. No, route is not there in the table. So what is the issue over here? Let me tell you the issue. Got the issue? Let me tell you the issue, guys. For an example, I have two router, R1, R2. Two routers are there, R1, R2. Here I have one loopback 1.1.1.1. Here I have one loopback 2.2.2. This is just a loopback, and I have enabled MPLS over here, MPLS and MPLS. Right, MPLS is enabled on both the router. Will LDP neighborship come up? If you are thinking yes, then you are wrong, guys. LDP neighborship will not come up between router 1 and router 2, because router 1 is going to use LDP identifier. What? LDP identifier will be 1.1.1.1 on router number 1, and LDP identifier on router number 2 is 2.2.2.2. Now here you have to make reachability between 1.1.1 and 2.2.2, right? Because before sending LDP message, it is going to exchange TCP message, SYN plus ACK and ACK, right? And source is going to be what? LDP router ID. If I will capture this link here, see, in this case, if you want to form LDP neighborship, you have to configure any IGP protocol. You have to make reachability between 1.1.1 and 2.2.2. You can configure a static route, you can configure dynamic routing protocol, then better. Okay, so if I am going to capture this link, right, and here if I will check LDP message, so this LDP message 23.1.1.3 for an example. Not this is LDP message. Let me show you the SYN message. Here is the SYN message. Fine. SYN message. In the SYN message, see guys, source IP address is what? 30.1.1.1. Source IP is 30.1.1.1 in the SYN message. Destination IP is 23.1.1.2. So router 2 will give acknowledgement to whom? To 30.1. Router 3 is sending one SYN message where source IP is 30.1.1.1, destination IP is 23.1.1.2. So router 2 will give acknowledgement to whom? To 30.1. And is route available for 30? No, route is not available. Right? So that's why here we don't have LDP neighborship between router 2 and router 3. Right? And this is the reason why router 2 don't have label 4.4.4. This is the reason why router 2 don't have label for 4.4.4 and router 2 is dropping the traffic in this case, right? So what will happen if I will remove loopback 10 here, 30? Then what will be the LDP neighbor? LDP identifier, it is going to be 34.1.1.3, and which is reachable from router number 2 as well as from router number 4 through OSPF, because we are running OSPF protocol here, right? So let me say here no interface loopback 30 interface loopback 30, and I am saying no to this. Either I can remove this loopback, sorry, not 30, it is 10, right? So either I can remove this loopback or I can configure LDP identifier manually, router ID. Now you can see here we have LDP neighborship. Now we have LDP neighborship between router 2 and router 3, even between router 3 and router 4. So once LDP neighborship will come up, you can check R2 LDP neighbors table again, and now you can see 2 neighbors are there. And now if you will check forwarding table, so MPLS forwarding table, you will have label for 4.4.4. You can see label for 4.4.4 is 18. Now router 2 is going to swap the label to 18, and then it will forward the traffic. It will forward traffic from which interface? From fast Ethernet 1/0. Next hop IP is 23.3. It will forward traffic to router 3. When router 3 will receive it, again router 3 is receiving labeled packet, so it is going to check their forwarding table, MPLS forwarding table. In the MPLS forwarding table, where is label 18? Here is the label 18, and this router need to pop the label. So router 3 is going to remove this label, and then it will forward traffic from F1/0. Next hop IP 34.4. So it will remove label and it will forward traffic to router number 4. Right, and then router 4 is going to receive unlabeled packet, normal IPv4 packets. It will check SAP table and then it will forward traffic to customer edge router. And now I am expecting the ping. Let me check again the reachability from router number 5. I am going to ping again. Ping 20.1.1.1 and source 10.1.1.1, and this time ping should work, and you can see ping is working. So now you can see side 1 and side 2 of customer are able to communicate with each other. Even router 2, router 3 don't have route. This is simple topology. Even in the real time between P to P you will have MPBGP, right? Here on the P router you will have VRF to separate the customer routing table. But this is so simple topology when we have single customer on both the P router, right? So this was the small issue guys in the service provider network which we have fixed, right? And if you want to learn these concept MPBGP, VRF, VPN, L2 VPN, L3 VPN, then definitely you need a proper training, right? And if you are looking for any training paid course, you can visit pmnetworking.in, which is my website. And even so many videos are available on my YouTube channel. You can check out MPLS playlist where you can learn the service provider network in detail. Okay, so here was the small issue which we have fixed it. Hope this video was helpful for you and you have understood the issue. If yes guys, if you have learned something from this video, then please hit on like button. If you have any question, query, concern, please let me know in the comment section. If my videos are helping you, if you are learning from my YouTube videos, just type yes in the comment section. It will motivate me to make more videos like this. Because once you will type yes in the comment section, I will get to know that these videos are helpful for you. You guys are learning from these types of videos. I will try to upload more videos like this. That's all for today. Thank you so much for watching. I will see you in the next class. Till then, stay safe. Bye bye.